So hello, welcome back guys once again in this video, and in this video we are going to solve the next problem of our ongoing DP series. So for those who are coming for the first time, so we are solving FRAZ DSA seat and we started with dynamic programming section. So we have finished all the problems of linear DP and one problem of two-dimensional DP. So if you are new to DP, try to start with the linear DP. Otherwise, if you are already have basic understanding of dynamic programming, you can start first. I would suggest you to first go and watch the coin change to video, and then after come back and watch this video. Okay, so let's open it and try to read the statement. So this is the problem. So the problem says that the chase knight has a unique movement. It may move two squares vertically and one square horizontally, or two squares horizontally and one square vertically, with both forming the shape of an L. The positive movement of chess knights are shown in this diagram. So for those who don't know about chess, so let me tell you the movement for knight, how knight moves on the chessboard. So let's say this is your chessboard. This is just a dummy chessboard. So let's say this is not actual chessboard. This is just a dummy chessboard. Let's say your knight is here in this cell. So the knight has capacity to move from this cell to either this cell or this cell. Okay, sorry, my mistake. This cell to this cell, or this cell, and this cell, and this cell. So knight has a capacity to move from this cell to any of the cell that is any of the cell that are highlighted here in a one move. So this is the property of chessboard knight movement. Okay, now let's come back to the problem. Now similarly, we have a chess knight and a phone pad as shown below. The knight can only stand on a numeric cell. Okay, so just assume this board that is given in this diagram as a chessboard. Okay, and what is going on, that let's say your knight is at position 1, so he can move to either 6 and either the cell marked as 6 or the cell as marked as 8. Okay, so this is the movement if your knight is moving in this dial pad. Now what is the actual question asking? So so given an integer n, return how many distinct phone numbers of length n we can dial. Okay, so you have to find out the different possibility possibility of length n numbers which can be formed by movement of this knight on this dial pad. And one more thing is given that you are allowed to place the knight on any numeric cell initially, so you can start placing your knight at any of the cell in the dial pad, any of the numbers on this given dial pad. Okay, so you can start at any cell, and you have to move the n minus 1 steps with the help of this knight, and you have to generate the phone number. So you have to find out the total number of different possible numbers. So okay, now here one more thing is given, that as the answer may be very large, return the answer modulo 10 to the power 9 plus 7. Okay, so the number of ways are large, so you have to return the mod value of the answer. Okay, so let's start the understanding and try to run some of the cases on the whiteboard. Okay, so let me share it once again. So first thing, I think we are well aware of movement of night on the board. Okay, this is one thing. So we already know how night moves. Now second thing, we have to make n length phone numbers. This is one important thing that is given in the problem. Second thing, we can place our night at any cell in start. Okay, so this is now let's try to create the board. So our dial pad looks like this. We have okay, we have 3 columns and 4 rows. Okay, so let me write the numbers: 1 2 3 4 5 6 7 8 9. This is 0, and here you cannot start, so let mark it as star. Okay, now one thing that we have to know, that we can start at 1, start with 1, or start with 2, start with 3, start with 4 5 6. We can start with any number. Okay, so let's in this case let's try to just see how many numbers we can make. If our n is 2, we have to make 2 length numbers. Okay, now let's say I'm starting with 1. So if I am at 1, so I can go here, I can go here. So first thing is 1, I'm starting at 1, so 1 length is 1. Now I can either move to 6 or move to 8. So one option is 1 6 and one option is 1 8. Okay, now there is any other option? No. This movement is not possible, this movement is not possible, here not possible, not possible. Okay, so this is starting with 1. Now 16 and 18. Now with 2, I am starting with 2, so first number will be 2. So 2 से हम कहाँ जा सकते हैं? 2 से इधर जा नहीं सकते. Either I can go to 9, either I can go to 7. इधर भी नहीं जा सकते, इधर भी नहीं जा सकते. We cannot go, we can only cover 7 and 9. So with 2 also we have 2 possibility. Let's try to let me first clear this board and make the copy of it. Copy, paste. So let me with 1 we have option of 6 and 18. With 2 we have option of, I can go 9 7. I cannot go here, I cannot go here because there is no any cell, so I can go to 7 and 9. Okay, so with 2 we can generate 2 numbers, 27 and 29. Similarly now 3, let's start with 3 से start किया. I can go to 8, I can go to 4. I cannot go here, I cannot go here, I cannot go, इधर भी नहीं जा सकते, इधर भी नहीं जा सकते. So we have 4 and 9. So with 3 we have 3 4 and 3 9. Okay, similarly let's try for 4. सो 4 से स्टार्ट किया, 4 से 9 पे जा सकते हो, 3 पे जा सकते हो, और कोई पॉसिबिलिटी है 0 पे भी जा सकते हो, ठीक है। 4 से 0 पे जा सकते हो, 3 पे जा सकते हो, 9 पे जा सकते हो। तो 4 3 4 9 एंड 4 3 4 9 एंड 4 0. So this is one possibility. Okay. Now let's start with 5. 5 से we are at 5. If we are at 5, we cannot go here, we cannot go here, because this is not option, this is also not option. We cannot go here, we cannot go here. So with 5, 0, no possibility, no possibility. Similarly 6 से this one, and also 3. With 6 we can cover 3. 6 1 6 7 6 0. Okay. Now 7 से इधर नहीं जा सकते, 7 6 एंड 7 2 इधर नहीं जा सकते, तो 7 से 7 6 and 7 2 we can cover. Now 8 से 8 से if we will start with 8, so 8 से 8 1 we can cover, 8 3 we can cover. Okay, so 8 से 8 1 and 8 3. Any other possibility? No, there is no other option. Here only I am writing with 9. 9 से we can cover 9 2 and 9 4. We cannot cover this cell, so 9 से 9 4 and 9 2 we can cover. Okay. 0 से if you start with 0 से 0 6 0 4, and there is no other possibility, so 0 6 and 0 4. Now if you will, so we cannot start with this, because there is no number there. So if you see all the possibility, you will see that यहाँ पे 2 मिला, here we have 2, here we have 2, here we have 3, here we have 0, here we have 3, here we have 2, here we have 2 with 8 and with 9 plus 2, and here we have 2 with 0. So overall, if you sum all the different numbers, 2 plus 2 plus 2 6 plus 3 9 plus 3 12 plus 2 14 plus 4 18 plus 2 20. So you'll see you have overall 20 possibility, which is the desired answer for this n equals to 2. So how will we solve this question using dynamic programming? So as simple as that, what I taught you, our special formula, our special formula. The first thing is, in our special formula is define your DP state. Okay, so define your DP state means our DP of I and J. So in 2D DP mostly we have 2 states. Most of the problems we can solve using 2 states. So what DP of IJ means? So DP of IJ means number of ways to create phone number of length j where the last element of the sequence is not sequence is not good word, last number of the phone number is I. ठीक है. So this is our state of DP. Let's try to clarify you a bit more. So let's say मेरे पास we have DP of 1 and 1, DP of 1 2, similarly DP of 1 and 9 and ठीक है. Sorry, we have DP of 2 and 1, DP of 3 and 1, similarly DP of 9 and 1 and DP of 0 and 1. So let's say these are the states we have. Let's say just assume that we have computed some way. So for DP of 1 1, let's say for all, let's say just we have one way. Now, so what does it mean? What does this states mean? Means कि we have. So if I will try to write definition of this particular state, so I have phone number of length 1 which is ending with 1. Similarly, इसका क्या मतलब हुआ? I have phone number of length 1 which is ending with 3. So if you similarly the definition for other states are as similar to the these ones. Okay, so now let's say in future, so what is our future, that we want to compute the length for length n, and it can be the last element can be either 0 1 2 3, out of 0 to 9 it can be anything. So we are computing this thing. So let's say just for example sake, if I am computing DP of 1 and 2, पहले इसका मतलब क्या? What does it mean? It means I want to know the number of ways it is not computed yet. If it is not computed yet, it means I want to store the number of ways to number of ways of phone number with length 2 which is ending with 1. Okay, so now I will, this is what we want to know. Now let's say मेरे पास ये अब बोर्ड आ गया, just amazing, this is board. So 1 2 3 4 5 6 7 8 9 0 -1 just represent there is nothing there. Okay, now here what I want, here I want 1 2 means number of ways which is ending with 1 and phone number which is ending with 1 and length is 2. So इस वन पे कहाँ से जा सकते हैं? So just if you try to see from in this grid, if you are at 8 you can go to this one. If you are at 6 you can go to this one. Okay, means ये 1 अगर इसको थोड़ा सा अलग वे में ट्राई करो सोचने का, तो लेट्स से DP ऑफ 6 1 तुम्हारा 1 है और DP ऑफ 8 1 भी तुम्हारा 1 है. मीन्स कि तुम्हारा वो नंबर, तुम्हारा नंबर ऑफ वेज ऑफ फोन नंबर जिसका लेंथ 1 है और वो 6 से एंड हो रहा है, उसके एक तरीके हैं. अब ये 1 जो है वो या तो इसके आंसर के आगे लग सकता है, 6 के आंसर के आगे लग सकता है. मीन्स लेट से 6 के साथ ये 6 ही था और 8 के साथ ये 8 था. दिस वन कैन बी एडेड विथ दिस 6 एंड दिस वन कैन बी ऑल्सो एडेड विथ दिस 8. सो जितने भी नंबर ऑफ वेज इनके थे, अगर उनको जोड़ दो, उनको प्लस कर दो, तो वही तुम्हारा डीपी ऑफ 1 2 बन जाएगा. यस ऑफ कोर्स बन जाएगा, क्योंकि 1 जितने भी नंबर ऑफ वेज हैं तुम्हारे उसके, जहाँ से तुम 1 पे आ सकते हो, तो उस उतने अगर उसके आगे ही तुम्हारा उसके लास्ट वाले, लेट्स से दैट लेंथ इज लेंथ -1. सो इफ यू ऐड 1 टू द एंड ऑफ दैट फोन नंबर, it will be of length length. Okay, so we will follow the same technique to solve this problem. Okay, so we will these are the states that are interdependent. So if I will try to tell you in a general term, so let's say if your dp of I and j you want to know, so you can append this I to all that sequences, all that phone numbers which are of length j minus 1. And here what are the possible values जहाँ से तुम I पे आ सकते हो? all case from where you can reach to I. Okay, so this is the obvious solution for this problem. So we got our first steps, how we are defined our state. Now the second thing we always used to do is, second thing is solving smaller problems. So in this case the smaller problem is length 1 problem. So all the dp of 0 1, dp of 0 2, select dp of dp of 1 1 to dp of 9 1 means 0 से एक लेंथ का 0 ही होगा, मीन्स 1 वे होगा और वो नंबर 0 होगा. dp 1 1 1 वे number itself. So similarly it's a 1 way the number itself. So one length is always the number itself. Okay, and we already see the answers that how can we compute for the further future states like greater lengths. So we will use the answer for the smaller length and we will try to compute for the answer for the larger length. So this is the overall transition state for the this dp. So now let me write it. Third thing, general equation. So our dp state will be look like num and some length. What we will do, we will try for all length, and then for each length, so for each length we will do try for all number, and in this you will get the current position, and you will also try that from which position you can come to current position, and then you will add the answer of length -1 to the current answer. So this is just a pseudo logic. We will see the complete logic in the code. So our one thing, we have defined our DP state. How we will compute? We have we know that the night movement, the movement of the nights on the dial pad. So let's say our one more challenges we have to get the positions of each number. So for that, what we will do, so let's say this is number, so we will create matrix. So we will write this star and has as -1, and we will create the matrix of 4 by 3, and we will represent our all the numbers. Now all the numbers, okay. Now we have to do one more thing, that we have to store the coordinates. We have to store the, we have to store the coordinates of every number. Why? I will tell you. So for 1 it is 0 0, for 2 it's 0 1, for 3 it's a 0 2. So similarly for every number we have to find out the coordinates. Now because let's say we are computing for answer 1, so from where we can come to this one? So we know that the night movement is we have already saw how night moves on the board. So night will either come from here or come from here. So how will get that? I will get that coordinate. So for that we will try to loop over all the possibilities. So what are all the possibilities? So let's say your current is I and J. You are at IJ location. So if you are at IJ location, so from IJ the night movement will be something like that: I plus 2, J minus 1. So you are here. So here you can go. Here you can go. Here you can go. Here you can go. For this it's like a, this is your IJ. You are at I and J. So let me write in an ordered manner. So if this is up, this is left, right and down. So in up there are 2 moves. So it's like I minus 2 and J minus 1, and I minus 2 and J plus 1. Okay. For up, these are the possible coordinates. For left, you are I minus 1, J minus 2, it's a I plus 1, J plus J minus 2. Left right के लिए it's a I minus 1, J plus 2, I plus 1, J plus 2. And down, for down it's a I plus 2, J minus 1, and I plus 2, J plus 1. These are total 8 possibilities. So what we will do, we will create one dx array and dy array, and it will be like -2, minus 1, plus 1, minus 1, plus 1, plus 2 and plus 2. Similarly for J, -1, plus 1, minus 2, minus 2, plus 2, plus 2, minus 1, plus 1. So these are the pairs of each coordinates from where you can jump to the particular IJ if that is inside the board. Okay. So let's try to so this is the overall idea of the problem. You will get more understanding while we write the code. So let's directly jump to writing code. So first thing what I have to do, the very first thing I have to do is I have to create this board. So for that I will create 4 into 3 matrix. So it will look like, So this is 1 2 3, then 4 5 6, then 7 8 9, and I am representing star as -1 because that is not a valid move and has as also -1. So we have created our matrix. Now the second thing, we have to know the coordinates of this. For that I will create map of unordered map of int and pair. So pair will store the indices. So let's say MP. I will traverse over this matrix I plus plus, and for int j equals to 0, j less than 3, j plus plus, and MP of mat of ij. For that particular number I am storing the coordinates because I need the coordinates on this board. Okay, now we have prepared these two things. The third thing is we have to create our DP array. So DP array will look like int DP of number. So number can be at max. So let's say for safer side, we have at max from 0 to 9. So we have 10 numbers, and your length will be n. So for n we have to create this something like that. Now our definition of state, we will reset our DP 0 size of DP. So let me write the definition of this DP also. Number of ways to create phone number of length j DP of I j. Number of ways to create phone number of length j where the last element is last digit of that phone number is I. Now we have defined our DP state. The next thing, we will try for all the lengths. So length will be from 1 to length less than equals to n, length plus plus. We will try out all the numbers from 0 less than equals to 9, and num plus plus. Now we have to know the current position, because what we forgot, we have to also write the answers for the base cases. Okay, so for that what we will do, for I will try for all the numbers num less than equals to 9 and num plus plus. For all the numbers, DP of num and the length 1 will be always 1, because the number itself is the last digit of the phone number. Now we have already discussed this. Now for the length 2, so we have to anyway start with 2. So for length 2, we know that we have to find, we want to insert number as a last digit. So whatever the current number we are iterating over, that is we want to put at last digit. So for that we need answers from where we can come to that particular dial pad using night moves, and what is the number of ways for the number from where we are coming, and the length is length minus 1. Okay, so we have discussed on the board. So for that, first we have to know the current position. Current position x is current position, so it's better write x. X is the current coordinate. So it is current coordinate we can directly get from MP of number dot first, and y coordinate will be MP of number dot second. So this is what we got, but now we have to know from which coordinates I can come to that particular coordinate, this current coordinate. So for that we need our dx array and our dy array. So it will be like, so let me write it, -2 -2 -2, here -1 and +1. Okay, now plus 2 plus 2. So this is for the first two pairs are for up movement, and this second pair is for down movement. So we are moving to +2 on the x coordinate and -y, -1 and +1 on the y coordinate. Similarly, if for left we are -2 -2, and here -1 +1 and +2 +2. For right, -1 +1. So these are the all pairs of the, so dx0 dxi and dyi is the pair of all the possibility, all these positions for the knight movement on the chessboard or the dial pad. So what I will do, I will try to for iterate over this. So there are total 8, so I will iterate on k equals 0, k less than 8, k plus plus. Now the destination x, let me write as nx and int ny. So this is destination x and destination y. So destination x is mp of, so first x में dx k जोड़ दो and y में dy k जोड़ दो. Now, so this is our new coordinate, but this coordinate can be anything. So we have to validate that coordinate, at whether that coordinate resides inside our given box. So for we have discussed that for 5 there is no, so for 5 there is no left movement or right movement, because even the -2 or +2 in a y direction will be outside of the board. So for that we have to take care. So we will just write if of nx greater than equals to 0 and ny greater than equals to 0 and nx less than 4 and ny less than 3, and also mat of, means nx and ny not equals to -1. So one more thing we have to take care that we cannot actually go from this star and hash. So for that I have write this check that destination coordinate cannot be the coordinate of x and y. So that is the way to check it. Now what I will do, so my current dp of num and length will be updated with dp of, so here length -1, but how we will get what number is present at that this current destination coordinate. So we can directly get it from our map. So mat of nx and ny, whatever the number that is present at that coordinate, we can get it from the matrix. So that is the number, and whatever the dp answer for length -1 for that number is, we will add into the current answer. And we have to also do one more thing, because the number can be very large, so we have to mod also. So 1e9 plus 7 we have to mod it, because it is given in the problem. here you can see modulo so here I will dp of number length mod equals to mod. Now so in this way we have already computed all the answers in the dp, right? So we have computed all the answers for all the numbers for all the lengths. So now we have answers in dp for each and every number and for the length n. So what we will do, we will add all the numbers all the ways for each number with length n. So int answer equals to 0 for int I equals to 0, I less than equals to 9, I plus plus dp answer plus equals to dp of, so it's better, let me write it's num, it will be more meaningful. So dp of num and n is the length given, final length. Now we will return one more thing we have to do, answer mod equals to 1 in 9, it's mod, we will return final answer. Okay, so let's try to run it, whether everything is correct. So what's wrong with this? Something we missed. What we missed here? For expected member name or after declaration specifiers, what we missed? Anything wrong? dp num of n. I don't think we make character line 44 whether we have already declared this answer somewhere. No, we haven't declared. What we missed? Num less than equals to 9 and num plus plus. So this is correct, line number. After declaration, so my internet is connected on, so why it is showing line number 44? We missed it here, unordered map. Now it should give the correct results. Is there any so is this semicolon only? This is semicolon only. Answer plus equals to int answer dp of num n and answer mod equals to mod. We have declared it as mod only. What we are missing? I'm not getting it. What is this error for? Let's try to run it once again. So let me do the quick debugging. So if is there anything, return answer. So we have to return integer only. So let me write this is fine. This is mem set dp0 select. This is also fine. This is also fine. This is also fine. Oh, now started here. This is also fine, and this is also fine. This is also fine. Okay, and with unknown value cannot be used in constant. Anything wrong? 10. End of the declaration. Return answer. Oh, we missed this. We missed anything else? DX. Yeah, this is array and this is array. Anything? What's wrong with DP? Oh, so many mistakes today. DP, where I wrote DP, maybe here, maybe here. So it is correct only. Mat of nx and y and length -1, that is correct. Now what's wrong? Oh, I missed something. I don't think so. Yeah, it should give correct answer. What's wrong? Percentage equals to mod. Oh, this is wrong. Okay, there is something wrong here, so let's try to debug it. So we are finding out the current position here only, and we are also iterating from 0 to 9. That is correct. Let's see this. So here it is correct, and this is also correct. Oh, above everything is correct. Now now let's look on the dx array. -2 -2 -1 +1, that's fine. -2 means up and -1 +1 means y coordinate. +2 +2 means down. -1 +1. -1 +1. -2 means -2 means left, and then -1 +1. That is also true. And +2 means right, and -1 and +1. So here while writing code you have to be very focused, because now it is giving correct answer. Let's try to submit it. Let's see whether it is giving correct result or not. So it got accepted. So we have successfully solved this problem. Let's talk about the time complexity. So we have 3 nested for loops. So this is constant time, and here we are iterating over length. So let's try to derive the time complexity. So time complexity will be so it will be, we are iterating over length, so it will be length into length means maximum n, into we are iterating over 10 numbers, into 10 into we are also iterating in the 8 direction for every number, so it will be 8. So it will be order of n only. Space complexity space complexity will be order of n into 10. This is because you have created dp of 10 and length, so length is at max n and dp number is at max 10. So this is the time complexity and space complexity of the problem. So let's mark it as completed, and tomorrow we will see the third problem, and till then keep coding, keep learning. Bye bye.